Well, what if it's a semicircle? All right, so again, if we're talking about a semicircle, now we're looking at that situation right there. There's a whole bunch of semicircles coming off of the board, and you can see the flat edge right there. So we want the sum of the areas, right? Well, what's the area of a semicircle? Well, what's the area of a circle? Pi r squared, yes. We want a semicircle, so that's just going to be pi r squared over 2. All right, so a mental note here, pi r squared over 2. All right, so that means in order to find this area, we need the radius. Well, be careful here, because the radius is not the entire length. Remember, this entire length is f minus g. All right, we know that this entire length is f minus g. Okay, but we only want the radius. So that's f minus g divided by 2. So if we stick that into our formula there, we have pi, and then we have the quantity f minus g. That's being squared, but it's over 2. All right, because that's our radius. And then the whole thing is over 2. Right? So what does that mean? Well, if we simplify this, we still have our f minus g squared, just like we did in the previous one. All right? So let's get that in. All right? It's wrapped and squared and dx. What's the coefficient going to be? Well, we've got pi in our numerator, and then f minus g is being divided by 2, but this 2 is being squared, which means it's really divided by 4. But then we're also dividing by this 2. If you divide something by 4, and then you divide it by 2, what are you actually dividing it by? Yeah, 8. All right, so our coefficient is pi over 8. If it's an isosceles right triangle, well, now, again, here's my isosceles right triangle. Okay, isosceles right triangle. These are coming up off the screen, so here's my f minus g. But I also know that my height is going to be the same value since it's an isosceles triangle. Right. So again, when I do my area, I have base times height, so that's f minus g squared, but a triangle, so we want half of that. So my coefficient will be half, and then f of x minus g of x squared dx. And then for BC calculus, last but not least, the equilateral triangle. All right, so if it's an equilateral triangle, this is going to require a little bit of work here. So let's get our equilateral triangle going. All right, there, that's close enough. All right, f minus g is the base of the triangle. We have a whole bunch of isosceles triangles coming up and pointing at us. Okay. Well, area of a triangle, once again, is 1/2 base times height. So we need the height of our triangle. This is an equilateral triangle, so we know that we have 60-degree angles. This is a right angle, so we now have that 30, 60, 90 situation happening. All right, so we need the height. We're interested in that length right there. That's the side opposite the 60. We know that that side opposite the 60 is the square root of 3 times the length of the side opposite the 30-degree angle. All right, so here's my 30-degree angle. I want that distance right there, which is going to be not the entire way f minus g, but rather just halfway. So that's f minus g all over 2. And then, again, because 60 is radical 3 times that, I'm going to have up here, let's see if I can get rid of this one now, I can have radical 3 over 2 f minus g. All right, that is going to be my height. All right. Now I'm going to bring this one back. Right? So I know that my whole base is f minus g. My height is radical 3 over 2 times f minus g. My parentheses there. So when I multiply them, I'm going to have radical 3 over 2 times f minus g squared. That's base times height. But again, it's a triangle, so it's base times height over 2. So when I multiply these two, I also have to divide that by 2, which means since I'm dividing by 2 and by 2 again, I'm actually dividing by 4. So my coefficient is root 3 over 4, and then once again I've got my, still doing my shorthand there, f of x minus g of x, that quantity squared dx. So you can see with all the shapes, it's upper curve minus lower curve, wrapped in parentheses, squared, and then there's some kind of coefficient. If it's a square, the coefficient's 1, so that's, I guess technically it's 1 there. If it's a rectangle, it'll be k, semicircle, pi over 8, isosceles right triangle, 1/2, equilateral triangle, radical 3 over 4.